Hello everyone, my name is Ayush Singh and today I will be discussing the problems I have solved on the topic of binary search tree, of course, DSA and C++. And I will be conversating in English from today onwards in the light of upcoming placements. So the first problem was from Brainsteller, father of lies. This is a basic but very important problem, so don't miss this. After that, we will be going through four easy problems: floor in BST, seal in BST, kth smallest element in BST, and two sum input is a BST. Okay, so here basically we are given a target and we have to give a number which is just equal to or smaller to it. Let's say we are given key 87. So we need to find a number equal to 87 or just smaller than. We found 87. So we given 11. So answer will be 9. So either equal to or just smaller. We are given 5. So there is no number either equal to 5 or smaller than 5. So answer will be -1. Okay. So floor is either equal to or smaller to. So this was an easy problem. So just write a condition. If root data is less than equal to target and our root data is greater than answer, we have kept answer as 1. We will keep updating the answer at each time step. Yeah, at each step. And later on we will do simple recursion. Same problem is for seal. In the seal, we have to go for either equal to or greater than. The condition will change a bit. Initialization will be with int max, the rest will remain same. Now we have kth smallest element in binary search tree. Okay, similar to this problem, we have kth largest element in binary search tree. Okay, kth smallest or kth largest element in binary search tree. So in binary search tree, we have a condition that in the in-order traversal, when we basically do the in-order traversal of binary search tree, it is in a sorted order. So I will use that condition. First, I will get the in-order vector. Basically, in the in-order vector, I will store the vector in in-order form, and then we know that it is already sorted. So simply, I will use k-1. We need the kth smallest element. No? Simply k-1. We got the answer, and there might be other ways also, but this is way simpler. And a similar method is we have to tell that whether the two numbers we have, like given a binary search tree, we have to tell that okay, we have two nodes whose sum is equal to target. We have the k basically is target. Let's say here is target is given 9, so we have 3 or 6. Answer is 2. Okay, answer is 2. Here is 28. We have to find that if there are two nodes whose sum is 28. If no, then return false. So first of all, I created the in order. Like in order is very helpful here. Basically, using in order in binary search tree, you get a sorted list, sorted vector. So once we have sorted vector, it's very easy. Then I initialize I with 0 and j with n-1. Then I started traversing with a while condition. I got the sum. If sum is equal to target or k, return true. If sum is greater than k, reduce the j. If sum is less than k, I plus plus. This is a basic problem. Like we have solved this problem already. Now the problems we were discussing, binary search tree iterator, size of large binary search tree in size of largest binary search tree in binary tree, maximum sum binary search tree in binary tree, and serialize and deserialize binary tree. Okay, binary BST iterator, size of BST in binary tree, max BST in binary tree, maximum BST, and serialize and deserialize in binary tree. These four problems are very important. Like it will take time to understand. But this part was simple. It was only saying that we have to convert this into certain format, like use any data structure. And after that, it was asking us to get these two operators, basically the function has next and next. So next will return the next node or element we have. Let's say initially with the, what we do. Achha, we started with we did first next we got 7. Okay, 7, 3, 15, 9, 20. Achha, there is level dot reversal. Okay, in that order. And when we has next, we're checking that if there is any value present or not. Let's say if we do has next at 20, it will false. If we do has next at 7, it will be true because we have 3. So I simply converted uses linked list concept. Okay, Let y dot reversal. This is simply creating the list. No? Okay, let me just repeat it, see it again what I have done. Great. Simple. We are simply using regression concept here also. If we in order left, in order right, and in between we were adding the nodes to the linked list. We have head, tail, and current. Okay, we have created the linked list and updated current with head, and simply this was very simple. You will check it, you will find the answer. Like this is the main thing was the concept I used. I use the linked list to solve for this. There may be other data structures, but I preferred linked list here. It was also very way much simpler here. Then these two ones are exactly same. First is size of largest BST in binary tree and maximum sum binary search tree in binary tree. So basically, we are finding binary search tree in the binary tree. This is the basic concept. Okay, so let me just explain this one. First, you have defined as class info. So it is containing max value, min value. It is BST or not, and its size. Okay, so basically we are asked size here. So we are showing size here. Okay, and this is our, so is just call solve function root and max size. Okay, so we won't go for less than 0. That's why it's keeping as a 0 here. Great. No, it's answer. Sorry. So basically, they're storing answer here. Answer. Okay, great. We are getting answer here. Okay, simple. We are having a recursive call here. We have the base case. If root is null, return max equal to int min. Min is int max. Is BST for null is true. Size also 0. Okay, and we then call info left and right. We define the current node. We got the current node size as left dot size, right dot size plus 1. Okay, current node size. Great. Then we check if left subtree is binary search tree, right is binary search tree, and the value we have at the root data is must be greater than left the max of the left, and the value of the root current node should be less than minimum of the right. Okay, this is the predecessor and successor concept. These two, and if it's true, then our current node is BST true, mark it true, and update the current node min max, and also update the answer. This is the answer max size. Answer with current node size, because our size is increasing bit by bit. And if it not, then current basis false, and set up the min and max as int min and int max. Okay, so this problem is exactly similar. I almost copied the code from the last problem, but instead here instead of the size we are getting sum, so we will doing add root val, and otherwise the entire problem is same. Just I replace this problem, define the different variable sum. Okay, and while updating the current sum, instead of doing +1, we are doing adding the root val. Otherwise you will see find the entire problem 100% same, nothing will differ. So I kept these two together so that if we need to revise it, we can do so. This was a bit difficult for me. I couldn't solve it, but let's discuss it. So what is saying it? You have a tree, okay, binary tree. We have to convert it into string, and then from string to binary tree. Okay, there are two functions here. First, convert the tree root node to string, and then deserialize like string to node. First part was a bit easier, like getting to string was easier, but deserializing is a bit difficult. Okay, let's just check out how can we do it. So, okay, we'll define a queue. If root is null, then simply return the empty string. If queue is not empty, okay, get the front, pop it, and we're checking only for the current node. Okay, so to string, adding the comma, and we're also adding left and right without checking it is null or not. If it is null, then it will later come as a current, and so it will go in else. This is simply putting has here. We could also do null, both will be the same thing. Okay, let me just show in what way we have to store. Okay, it is not showing here. Okay, great. While since we have got the string from the root using the concept of queue, like simply think of it like level order reversal. You can say it reversal. Okay, from, and we are removing the last comma here by using this. Okay, we got a string. Now we have to deserialize it. So here, this is the first time we're using the string stream concept. String stream ss. We put the data here. String val. We got the get lines ss string stream and val comma. This is like the part of the string before comma will be stored in val. So we have the val. We converted the val to integer and created a node to it. Use the same concept of q here. While q not equal to empty, get the front node and pop it. And also this two condition for left and right node. Okay, get the value of val. If val is not equal to hash, if it is equal to hash, well, it is empty. If not equal to hash, then create the new node and add this node dot left to it. Push. Okay, push. Great, great, great. Return root. Okay, okay, we are using this node dot left, node dot right. So our facility is getting created. I was a bit confused how we're doing so. Yeah, this is a bit tricky and also difficult, you can say, but if you'll give time, you will able to handle this. Okay. Okay, so basically now what we have to do is next part remaining is the binary miscellaneous. Let's see how many of these I could solve yesterday. Sorry, tomorrow. Okay then. Bye bye till then.